Picture a treasure hunt where every clue points to the next one. Can you swap each neighboring pair without rewriting the clues? Take 1, 2, 3, 4. After swapping neighbors, you want 2, 1, 4, 3. What should the new front be? Here is our example list, 1 to 2 to 3 to 4. The answer starts at 2, not 1. And notice, we are not changing values inside nodes. We must move the actual links between nodes. Pause before I say it. What would you try first if you were doing this by hand? The obvious approach is, grab the first 2 nodes and reverse that little pair. So 2 should point to 1. But now stop. What points to 2? Head still points to 1, so the list front is already wrong. And after that pair, we still need 1 to connect to the swapped version of 3 and 4. There are 2 links to repair, not 1. So the pain is not the swap itself. It is keeping the list stitched together while the front might change. Let's slow down here. Look what we know but keep throwing away. After each swap, we need a safe node before the pair. What do we wish we already had every time we start a swap? A handle to the node right before the 2 we are flipping. And here's the move. Add a dummy node in front. In a linked list, think treasure hunt, each clue points to the next, and dummy gives us a permanent starting clue. Now every swap looks the same, even the first one. Each time we relink the chain from prev, then walk prev forward to the next pair. You might be tempted to swap values instead. Don't. The problem says the nodes stay the same, only the links may change. Watch out for one more bug. Only swap when there are 2 nodes available. If 1 node is left, leave it alone. Indexing is gone here. We just keep a pointer called prev, starting at dummy, and look at the next 2 nodes. First swap. Prev points to dummy. First is 1, second is 2. Pause here. We must save where 2 should point next. Now reconnect in order. Dummy points to 2. 2 points to 1. 1 points to 3. That finishes the first pair safely. So what changed? The front is fixed automatically because dummy was sitting before everything the whole time. Then we slide prev forward to 1, the back of the swapped pair. That sets us up for the next 2 nodes. Second swap. Prev is 1, first is 3, second is 4. Reconnect the same way, and now 1 points to 4. Finish it. 4 points to 3 and 3 points to nothing after it. The list is now 2, 1, 4, 3. The loop stops because there is no full pair left after prev. Then we hand back the real front, skipping dummy. Notice what just happened. We never searched or rebuilt anything. We only rewired a few pointers around each pair. Each node is visited a constant number of times, and we keep only a few pointers. So time grows with the list, and memory stays constant. Let's write it. First, make dummy and let prev start there. That gives every pair, even the first one, the same setup. Then loop only while 2 nodes exist, and name the 3 pieces we need, first, second, and what comes after the pair. These 3 pointer updates do the swap, and then prev moves to first, which is now the back of that pair. Last line, return dummy.next, the real head after all swaps. Same treasure hunt, just with each pair of clues flipped.